So today, special right triangles, and what I want to do more than anything is first let's draw a 40. So if we're going to draw a 45, 45, 90 triangle, let's draw each side 4 centimeters. Okay, so I'm going to go 4 centimeters. I'm going to take my ruler. I'm going to go 4 here. And since it's a 45, 45, 90, I know it's half a square, right? So if it's 4 there, I'm going to go 4 here. Trying to keep it 90 degrees, so pretty sure that's 90, but I can check with my protractor, right? And yeah, I got 90 there. And so then I'm going to go ahead and draw this other side, right? So 90, 45, 45. All right, so what I know about this triangle is because it's a 45, 45, it's half a square, right? It's half a square. So I know these two sides have to be equal. It has to be 45, 45. I just took a square, cut it right down its diagonal, got the two equal sides. Now the third side, the hypotenuse, not sure what that is, but I could do Pythagoras Theorem, right? So if I want to find, say, let's just call it C for now. If I wanted to find that, okay, I can do that. I can go, okay, 4 squared plus 4 squared equals C squared, right? I'm just going to work out Pythagoras Theorem. That makes sense. I don't know what this length is, but I can figure it out. Or I can measure it with my ruler, but the problem with measuring with my ruler is it might not be super accurate, right? Could. But I want an exact answer. So let's do Pythagoras Theorem. So I got 4 squared plus 4 squared. So I got a 16 plus a 16 equals C squared, right? 16 plus 16 is 32 equals C squared, right? And then I'm going to take the square root of that. Now I'm going to be careful because I want an exact answer. Square root of 32. And I want it, and that is an exact answer. Square root of 32 is an exact answer. But we can probably fix that. We can reduce it like we did on our warm-up. So that's the same thing as the square root of 16 times the square root of 2, which makes 4 square root of 2. Okay, so C, the hypotenuse then is going to be 4 square root of 2. Well, it turns out that happens all the time. That happens all the time. In a 45, 45, 90 triangle, these two sides are always going to be equal, yeah, and the third side is always going to be whatever this is times the square root of 2. Always. In fact, it's such an important triangle. It's right here. In fact, if you take a look at what I have up here on these sides, I've got x, x, x squared is 2. So like 4, 4, and 4 squared is 2, right? So let's put this triangle in your notes so you always have it. So let's go ahead and redraw this triangle. I'm going to redraw it over here, but with x's, okay? So, draw my triangle, and I'm going to circle this when I'm done because this is my special right triangle. Okay, now, instead of calling it 4, 45, 45, 90. Now, instead of calling it 4 and 4, we want it to work for any triangle. Does that make sense? We want it to work for any triangle, so instead of 4 and 4, let's just use x and x so that these two sides can be anything, right? X could be 4, x could be 10, x could be 100, but x is some number. So these two sides are equal. Let's call them x and x. And then the hypotenuse is always, whatever this is, times the square root of 2. Always. If it's a 45, 45, 90 triangle, the hypotenuse is always x squared root of 2. Okay? Always. And I'm going to circle that. I know it's up here. I'm going to highlight it. But this is our special right triangle, our 45, 45, 90 triangle. Okay? It's really easy. These two are equal, and then the hypotenuse is always whatever this number is times the square root of 2. So let's look at example 1. So if I look at example 1, it says find x and y. Okay, well, here we go. I've got a 45, so I know for sure this side is also 45. I know I took a square because of the 45, 45. I took a square, cut that square in half. So therefore, this is 8, and the x has to also be 8. Okay, so this is also going to be 8, right? Because it's half a square. That's easy. Now the hypotenuse is always going to be whatever this is times the square root of 2. So this is going to be 8 square roots of 2. And that's the length, the exact length of that. Super easy. Faster than the Pythagoras Theorem, isn't it? It's faster. I mean, it's just 8 square roots of 2. If you did the Pythagoras Theorem, that's exactly what you'd get, but this is much faster. But it only works on a 45, 45, 90 triangle, okay? Only works. Okay, now, example 2. Just a little bit backwards. So if these two sides are equal, right, you know it's half a square, correct? So I automatically know these two sides are equal. That's a 45, and that's a 45, 90 triangle, okay? Because it's half a square. So the difference here is that we're given the hypotenuse. This is 18 square roots of 2. So the 18 square roots of 2 is sitting right where this x square roots of 2 is. So we already know what x has to be. It's just 18, right? You guys agree with that? So that means this side is 18, and this side is 18. Pretty easy, isn't it? Again, it only works on a 45, 45, 90 triangle, but it's much easier. Okay, again, because these two sides are equal, it's half a square. Does that make sense? And if I cut a 90 degree in half, it's 45, 45. Okay? Okay, now let's look at example 3. Now, example 3 is a little bit harder, okay? Because the 12 is sitting right where the x square roots of 2 happens to be, okay? It'd be nice if it was 12 square roots of 2, but it's not. It's just 12. So to find x, what we have to do is solve, okay? So the 12 is sitting right where the x square roots of 2 is. If I want to find out what x is, I have to solve. So if 12 is equal to my x square roots of 2, and if I want to find x, which is this side, I'm just going to solve. Well, that's easy to solve. I'm just going to divide by square root of 2 and divide by the square root of 2, okay? So x then, just divide by square root of 2, cancels. So x is equal to 12 over the square root of 2. Okay, now that's an okay answer, but we can make that better. I would take that answer. I would take this answer, but we've learned before with square roots that you're not supposed to have a square root in the denominator, right? So we fix it. We fix the square root. Remember we have this little rule that says you can't have a square root? Right, totally right. Zoe, remember. So you fix the problem with the problem, totally right. So you multiply by the square root of 2 over the square root of 2. Nice job, Zoe. And we wind up with 12 square roots of 2 over the square root of 4, right? Which is going to be 12 square roots 2 over 2, right? Which makes it 6 square roots 2. All right, that's this side right here. That's x. So x is 6 square roots of 2. And of course, because it's half a square, right? 45, 45. Y is also, because they're equal. 6 square roots 2. Okay, thumbs up so far?
Then why do they, I'm just confused, then why did they label it Y if they're the same thing?
I labeled it Y, just because you'll see when we flip the page we'll have different, okay? I could have labeled them both X landed. Okay, that's actually a good question. Okay, amazing how well you can learn when you're quiet and listening. You're helping yourselves. Thank you. Ashley.
So, how come the x and y isn't just 6? Why is it 6 squared of 2?
Great question. So the 12 should be square root of 2, shouldn't it? It should, but it's not. So the square root of 2 is still in the problem, but it turns out it's down here instead. Okay? So if you solve for x, 12 is at the x squared root of 2. If you solve for x, then the square root of 2 goes to this side. Okay? All right, turn the page, you guys. Now, what about the 30, 60, 90 triangle? So let's draw this triangle, okay? I want you to draw and follow along. I want you to make this side 2 centimeters. Okay, make this side 2 centimeters. Okay? And now we got to be a little bit careful because I'm going to draw straight up, but I might have to erase because I don't know how long this side is right here. I don't know. I have no idea. So I'm going to draw it straight up. And I might have to erase some of this because I don't know how long this is because I want to make the 4 right here. I want to make the 4 right here. Okay? Okay? I want the 4 right there, okay? So that this line I can then erase a little bit of it and make it fit. Let me double check my angles, okay? Let me double check my angles, okay? So my angles should be 60 degrees. Yeah, that's pretty close to 60. And should be 30 degrees Yeah, that's pretty good to 30. Okay, I got a 30-degree angle, if you guys can see that. I got about a 30-degree angles there, and I got about a 60-degree angle there, okay? So that's pretty good. That's about a 30, 60, 90 triangle. 30 degrees, 60 degrees, okay? Okay. Now, before we even start, do you notice anything about these two sides? It's double, isn't it? Isn't it double? Yeah, this is double. And that always happens. In fact, if you look up here, what do you see? You see x, and you see 2x, don't you? So it is always double. Now, what's this side? Well, if we do Pythagoras Theorem, let's call this a, we'd have a squared plus 2 squared equals 4 squared. So we can find this other side by Pythagoras Theorem. Okay? So I'd have a squared plus 4 equals 16, right? Minus 4 minus 4. I'd have an a squared equals 12. Square root it. And if we want an exact answer, I'm going to break down the 12, right? Yeah. Annie's way ahead of me. 4 and 3, which makes 2 square root of 3. Okay, so then this side here, we can put in, we just write it as 2 square root of 3. Okay, so here's what I notice. The hypotenuse is twice as big. You see that? If the little side is 2, the hypotenuse is twice as big. And the other leg is whatever this is times the square root of 3. So there it is. X is the short side. The hypotenuse is twice as long. And then the longer leg is always whatever this side is times the square root of 3. So let's put this triangle on our notes so we have the general form of 30-60-90 triangle. Okay, let's go ahead and draw that in. So I'm going to draw freehand the best I can a 30-60-90 triangle. Doesn't have to be perfect. I just got to make sure I get the x's in the right places. Okay, so okay, 60, 30, and 90, okay? Now, this only works on a 30, 60, 90 triangle. Only on this triangle does this work. Where the shorter leg and the hypotenuse is twice as big as the shorter leg, okay? Always, okay? If it's a 30, 60, 90 triangle, the hypotenuse is always twice as big as the shorter leg. But the longer leg is whatever this number is, times the square root of 3. Okay, let's go ahead and circle that because we're gonna need to know that in our next test. Okay, here it is. So it's pretty simple. Wish people wouldn't call me during school.
Maybe it's important.
Well, I'll get back to them. I know.
What if they're dying?
Well,
And they were like, let's call Mr. Davies. Hello, Mr. Davies.
so take a look. Okay, here's my triangle. So the hypotenuse. This is the hypotenuse. Hypotenuse is 12. You guys see that? Hypotenuse is 12. So that means the shorter leg is 6. Okay, does that make sense? Okay, so I know that if the hypotenuse is 12, the shorter leg is 6. And then the longer leg is whatever this is times the square root of 3. This is going to be just 6 times the square root of 3.
It's important, Mr. Davies.
I'm recording. Lenny, you want to check it? Okay. What is it? Unknown. Well, then we'll just let it stay unknown. Okay, now, number 5. So number 5, the 18 is sitting on the hypotenuse, right? So therefore, the shorter leg is what? 9. And the longer leg is? That's it. Isn't that easy? Okay. Okay, if this is 18, it's twice as big. The hypotenuse is twice as big.
This is just a 30. So we're 90 and 30.
Yes. Yeah, okay. Now, how about number 6? If it's an equilateral triangle, what are the angles? They are all the same. Perfect. And how? I heard it. How many angles are in a triangle?
3.
How many total degrees in a triangle? So each one would have to be. I thought I heard. Did you say it? I heard 60. 60.
I actually said it way quickly.
I heard somebody say real quietly 60.
I said 60, and then
Okay, you guys good, right? So if we want to find the area of this triangle, area of any triangle is going to be 1/2 base times height. Okay? So, all right, the base. I know the base, it's easy. The base is 10, right? So the area of this triangle is going to be 1/2 10. But then the height, I don't know the height. So let me draw in the height, because I know the height's going to be straight up and down. And because it's equilateral, it cuts it right down at 90 into 2 equal triangles. You guys get that? So it really does. Okay, it cuts it into 2 equal triangles. Okay. Now what happens then is this 60-degree angle got cut in half, right? So this angle becomes 30, and I get a 30, 60, 90 triangle, right? So if this side is now 5, you with me? 5 and 5, right? Because I cut it in half. Then the height is what? 5 square roots of 3. 5 square roots of 3 because it follows my rule, doesn't it?
Yeah.
Right? So then the height of the triangle is 5 square roots of 3. So okay, one more time.
Oh, I get it.
Okay, so the area is base, 1/2, base is 10, times my height, which is 5 square roots of 3. If I have an exact answer, I'd have 25 square roots of 3. If I wanted a decimal answer so that I can go to Marston's and they can cut a board for me because they'd look at me like I was crazy. If I said 25 square roots of 3, they'd say, what are you talking about? So I could just use my calculator, right? And I can go, okay, what is 25 times the square root of 3? Okay. 25 times the square root of 3, and I get an answer of about 43.3 or 43.3 centimeters squared. Okay? Yeah. Question?
Wasn't that the area of only one of them?
No, that's whole triangle because the base I let it be 10. Now, what could happen? Okay, now, almost done. Shh, almost done. Stop talking. Okay, Julia. Now, one more time, and I'm going to close up in a second, okay? If it's a 45, 45, 90 triangle, it will always follow this. X, X, X squared is 2. Always. If it is a 30, 60, 90 triangle, it will always follow that the hypotenuse is twice as long as the short leg, and the longer leg is always whatever this is times the square root of 3. Okay? If it's anything else, we have to learn something new, which we'll learn tomorrow. Okay, and that's all I have.